let's first just look at these segments that are intersecting. Is there anything special about those segments?
They're diameters.
They're both diameters, okay? Back to day 1 of this class. Can we figure out the other 3 angle measurements?
Yes.
Yes. Okay, what's the measure of this angle?
42.
Why?
Vertical angles are always congruent.
Vertical angles are always congruent. How do we solve for this obtuse
Subtraction
angle?
180.
Okay, why? And why do I know to do that?
Because it,
Linear pair. So that'd be 1/38, I think, if my math is correct in my head. Okay. So we can find these other angle measurements. These type of angles, because of where its vertex is, they have special names. These 4 angles are what type of angles?
just kidding.
This one angle, because its vertex is at a certain point, they have a
Oh,
certain
center angle.
central angle. Yeah, central angle. So we need to know, how are these central angles related to the intersected arcs? Remember, the intersected arcs are the arcs that are in the interior. So this angle here, angle SCR, it is intersecting arc SR. So we need to determine, well, what's the relationship between the central angle and the intersected arc? Who is that? The exact same, if it is a central angle. So the measure of arc SR would be 42. The measure of this arc would be 138.
And so forth. Okay.
What is the measure of major arc? SQV.
180.
180 degrees. What do we call that type of arc?
Semicircle.
Semicircle. Okay, sweet. Okay, so we've already gone over number 1, and those are. Were there any? Oh, that's all sweet. Were there any tricky questions? Like, did they make you add in auxiliary segments anywhere? For number 1. For number 1.
No.
Yeah, they did. Part E, the measure of angle QSV. So you had to add in that chord, QS, and then V. This is your angle. Well, what is the measure of that intercepted arc? 42. So how does this inscribed angle relate to the intersected arc? 1/2. So what is the measure of this? 21 is the measure of this angle QSV. Same thing with QVR. You had to add in 2 auxiliary segments. So you had QVR. I'm outlining a triangle right now. What type of triangle is that? Right. It is a right triangle because its hypotenuse is a diameter. That was the last theorem on that 3rd page of notes, at the bottom. So the measure of angle QVR has to be 90 degrees. So that's good. They're mixing it up and they're throwing some inscribed angles and central angles, and that's good. Any other questions on 1 through 4 on this page? Yes, sir.
Number 3, part H.
Okay, we're going to have to figure out what's going on in this diagram first. So it says, let segment BE be perpendicular to segment IS, and then also the measure of angle TOE is 36. Okay. And let me go ahead and figure out what we're searching for. The measure of angle TBI. Okay, what kind of angle could we call TBI? Using our new circular terms, not acute or obtuse or right.
Inscribed.
And if the vertex is on the circle, then what is it called, Caitlin?
An inscribed angle.
This is an inscribed angle. So how is it related to the intersected arc? It's 1/2. So if we can find the measure of this arc, then we will be able to take half of that and solve for the measure of that angle. Well, they gave us that this central angle here is 36. That means from T to E has to be 36 as well. What's the measure of arc EI?
90.
90, because that's a 90-degree angle, but it's a central 90-degree angle, so that means that this intersected arc has to be 90 as well. So add those two up. The green intersected arc, the measure of arc TEI, I guess we should only use 2 letters because it's a minor arc, sorry, is 126. So half of that would be 63.
Yes.
Measure that, 63 degrees. I'm absolutely sure there's other ways of going about it, but that was,
Probably the easiest.
well, just based off of what we were given, yeah. But your train of thought may have been different as you were solving for all of these angles and all these arcs. You may have saw how this angle was related to maybe this triangle or something. So there's all kinds of ways you can look at it. We can use the triangle sum theorem to figure out angles. So, but that's the way I solved it. We can leave like the quarters and stuff in the stacks. Okay, any more from 1 through 4 on 369? Let's go on to the next page, 370. On 370 it was 7 through 13.